Hi. In our last CEH class, we went through about, I don't know, maybe 45 of you filled out a survey, and I said, how many of you would say that you have a predominantly Cisco network? And it was unanimous. We had 45 out of 45 students say, yes, we run a Cisco network. And my second question was, how many of you would say that you have a purely Cisco network? Meaning it's Cisco wireless, Cisco firewalls, Cisco phones, Cisco, and nobody had that out of everybody who said we'd run a Cisco environment. And I said, well, how about your switching and routing infrastructure? Is it purely Cisco? And we had maybe 9 or 10 students that said, yes, we've got pure Cisco for switching and routing. And the majority of the class, about 80% or so, was saying that they actually had other vendors, such as Juniper, HP, Dell, etc. And these were typically multi-generational pieces of equipment, meaning a past manager approved some HP gear or some Dell gear, and we've got it in there working with our Cisco equipment. Now, a lot of the students were giving me some negative feedback on HP, and I just wanted to set the record straight that the way that HP does things is just different. It's not necessarily wrong. I want to go through call it a trouble ticket here of a server that can't reach the clients. He's in VLAN 20, the clients are in VLAN 10. We're not quite sure why that is, and it has to do with a little bit about the way that HP does things differently from Cisco. So if you understand trunking and you understand spanning tree, you should be able to follow this discussion without any understanding of HP. You'll just see that they do things a little bit different. So let's go ahead and get started. What we're going to start off with here is just an environment where there's 2 distribution switches and 2 access switches. So we've got 4 switches total. Up top, this is our distribution. Below, this is going to be access. Now, the access switches are going to be HP ProCurve 3500 YL. And the distribution switches are going to be HP Comware products. This is from their H3C acquisition a few years ago. And this is going to be a 5800 series switch. So what we have are not only not Cisco devices, but they're dissimilar HP devices. And the way that they behave is actually a little bit different. Each vendor has its nuances. And just like we've seen with Cisco, there's nuances between iOS and NXOS. There's differences between 12.0 and 15 in terms of what commands we have available, what some of the default behaviors are. HP is really not any different, but what we do have here are 2 very different operating systems, different command sets and everything. When we look at the real issue here, we've got a user that's basically the client, and they're going to be located in VLAN 10 at an IP address of 10.8.10.100. And then we've got a server over here. I'll put an S on it for server. He's going to be located at 10.8.20.100. And previously, everything was communicating properly. But when I came in this morning, server can't get to the client can't get to the server. Upon a little bit further analysis, we found that the server isn't able to communicate with anything off of the local switch. When we start looking at the connectivity between the downstream and the upstream switches, we've got port 1, which is connected straight up, and we've got port 2, which is used as a cross connect. So here's port 2 and 2, 2 and 2, and then of course our distribution switches are bundled together here. Spanning tree is running. That's one of the first things you might think about when I say we're having problems with connectivity and it's HP. I say that because HP does not use spanning tree by default, not on ProCurve or Comware. So if you were to install the switches in a rack, cable them like this, absolutely nothing would work. You'd have a broadcast storm, CPU would be at 100%, and we wouldn't have to go much further, right? So first thing we'd want to verify, is spanning tree actually enabled? We could check that out on our switches. What I've got here is our topology, 5800s above, 3500s at the bottom, and we've got our client as well as our server. If I was to look at, and I've got my terminal sessions laid out in the same order, meaning the bottom 2 windows are my access switches, access switch 1, access switch 2. On the top, we've got core switch 1 and core switch 2. If I quickly just do a display spanning tree, I can see that spanning tree is in fact running on these, and if I come back over here and do a show spanning tree, I can see here that it's also running. So the fact that spanning tree is on is pretty good news. I know that it's not the cabling, it's not layer 1 that's caused my issues, and I'm trying to get to a routing, right? I'm trying to discover why can't I get from VLAN 10 to VLAN 20, but I bet it has something to do with the layer 2 configuration. So I looked at layer 1, it's cabled as we've seen here. The links are up and they're good. Next, if we're not running spanning tree, we could have a broadcast storm resulting in a lot of packet loss. We're not seeing that either because spanning tree is running everywhere. What we would want to look at next is our actual spanning tree configuration. When we do spanning tree on HP, it's pretty neat. Let me show you. We'll come over here and I can do a STP mode, and if I question mark, you'll see that I've actually got support. This will probably surprise some of you, but there is support here for per VLAN spanning tree, or PVST, inside of ComWare. So we could do Cisco's spanning tree methodology. However, what we're using by default with HP is going to be Mstp. And when spanning tree has been enabled, this is what's actually running everywhere. The way that spanning tree has been configured in our circumstances is that we have 3 instances: instance 0, instance 1, and instance 2. Like we see in a lot of scenarios, what we've done here is we've set up instance 1 to be the root on what we'll call core switch A. And over here for core switch 2 or core switch B, we set him up to be the root for instance 2. And the reason that you set your different root bridges is that, remember, with your instances, an instance is just a spanning tree process. Think of it as stp.exe. It's not what it really is. That's what it would look like in a Windows file format. But this is kind of like what we have going on. And what you can do is assign different VLANs to different spanning tree instances. So as you go through and you take a look at your spanning tree region configuration, we can come back here and do a display Stp region. And what we'll notice here is that our region name is HP. The region name has to match everywhere. The revision level is 1. Great, that's got to match everywhere as well. Down here, you can see our 3 instances. 0, which is there by default. Everybody is an instance 0, except for those we assign somewhere else. We see that instance 1 has VLANs 1 and 10. Instance 2 has VLANs 6 and 20. So the way that that's supposed to work, the reason we carve out these separate processes is that all VLANs go under process 0. Under process 1, we've got our exceptions. In this case, VLANs 1 and 10. And for instance 2, we've got VLANs 6 and 20. So for example, 6 and 20 are supposed to be root on this switch, and VLANs 1 and 10 are going to be root on that switch. That's fine. We can still have routing decisions occurring because we've got connectivity between VLANs 10 and 20 between our instance 1 and instance 2s on the 2 different bridges. So again, our problem here is that the server can't seem to access the client. If we were to go look at our spanning tree configuration, we can see here that it looks pretty good, but this region configuration has to match everywhere. If we come over to the neighboring core switch, disp Stp region, once again, revision name is HP, revision level is 1, looks good. These revision names are case sensitive, so you got to watch those closely. You see down here we've got our instance mappings, 0, 1, and 2. Even if this was more complicated and it felt like it's a lot to read and you might be missing something, what you could take a look at is this configuration digest here. The configuration digest gives you the ability to look in there and just see the actual checksum that's being carried by the spanning tree BPDU from one switch to another. This is how they actually verify that one switch's configuration matches the others. So right there, those 2 switches look pretty good. We could come over here, do show spanning tree, and we want to see our MST config. and there we've got it. So HP, capital, revision level 1. Here's our digest. Ends in B4, kind of like what we saw over here. It's not capital, but this is hexadecimal, so don't stress out over it too much. And instance 1 for VLAN 1 and 10, 2 for 6 and 20. Looks pretty good. On our last switch, let's just come over here and do a quick show spanning tree. And I want to show you something. Under our show spanning tree, we can look at thought it would be in there. Let's just go ahead and take a look at that instance information again. Show spanning tree instance. Oh, MST config, I'm sorry. So cool. We go in here, and we take a look at it, and we can see right off the bat, if this didn't jump out at you, where is that B4 in the end of my digest? Not there, right? It says 59C, so something's off. Under a little bit closer inspection, I can see here that in instance 1, VLAN 30 has been assigned. So if we come back and look what happened, everyone has got a matching configuration except for access switch 2. So this switch has a config that doesn't quite match. When he sends out his BPDUs, they've got a digest that's different from the neighbors, core A and core B. So what happens because of that digest mismatch is that you have two different regions. You've got one region that consists of instance A, instance B, and access switch 1 down here. And then you've got a separate region with just access switch 2. Over here, he would be the root bridge for his own region. He's in a different environment because those BPDUs didn't match. You're still doing MSTP, and the other guys are still doing MSTP. The problem there is that they're not doing MSTP together because their BPDUs don't match. They wind up using what's called common spanning tree in the middle, and only one of these paths is going to be forwarding. Remember, when spanning tree is working properly, you've got VLANs 1 and 10 going over these links. You've got VLANs 6 and 20 going over these other links. So are we still blocking? Yes, but we're blocking 6 and 20 over that path on the left, and we're blocking 1 and 10 on the path to the right. That gives us that link aggregation, or not really link aggregation, but the capability to do load sharing. We can use both of our possible uplinks. When you look what's happening over there with access switch 2, because we've fallen back to using common spanning tree, one of these ports is simply going to be in the blocking state, and one of the ports is going to be in the forwarding state. Which one is it? Well, it depends who becomes the root of your internal spanning tree or common spanning tree, instance 0. What do we wind up falling back to? Now, the other thing that you have to pay attention to are your trunk links. When HP talks about doing trunk links, depends which HP you're talking about. HP ProCurve calls a trunk a bundle of cables. You're like, what? A bundle of cables? Well, with LACP, when we build an ether channel, if you do that under HP ProCurve, they call that a trunk. A little bit weird, but here's what they were thinking. All this IP telephony that we're doing, remember like IP telephony and phone systems or just IP communications, we're using twisted pair copper. Sometimes, a lot of times we're using fiber too, right? But when we started bundling these copper wires together, that's the same thing they did in the phone world, and it was just called a trunk. So kind of building off upon that old world telco terminology, they called their ether channels trunk links. So if you look at ProCurve terminology, a trunk is a bundle of cables. A cable that carries .1 queued frames on it is just called a tagged link. Tagged versus trunk. Trunk is a bundle of cables. Unless you're talking COMware. If you look at HP COMware, a trunk is just a tagged link, like what Cisco refers to it as. So that's just another point for a little bit of confusion when you're talking to other network engineers and when you're looking at the documentation. Not saying that it's right or wrong, it's a little bit goofy, but just be aware of it. So how does that get us into trouble? Well, a couple of things. First off, if we want to get our load sharing back, we've got to make our MSTP match everybody else's. So to make that happen, what we could do is, and if I show spanning tree instance 0, ACK. Doesn't like 0, wanted IST. Your IST or internal spanning tree is also known as instance 0. Notice here, it just didn't like that identifier. You can see here which VLANs are mapped. And we see that 30 is missing. So if you look at the way that that's behaving, we are the root. You see that? This switch is root. Anytime you see that on a non-root bridge, it means you're in trouble. It means something is not quite right with spanning tree. See, if I look at this guy, access switch 1, show spanning tree, instance IST, what we have here is the MAC address for our root bridge. We've got our own MAC address, but then we've got the MAC address of the actual root bridge. Over here, we don't have that because we think that we're the root. So how can we fix that? If we do a show run on access switch 2, we've just got to make his spanning tree region configuration match. So down here, where it says spanning tree instance 1, VLAN 11030, we'll just go into global config and make it match the other guys. And again, if we did it over here, show run, we'll run down to the bottom. Notice that its instance 1 is just VLANs 1 and 10. So let's get 30 out of there. Uh-oh, got some messages going on. What's happening up here is there's a topology change with Mstp. And what should happen is we'll start setting these BPDUs, and he should join back in. And we see here that this switch is no longer the root bridge on instance 0. We've got this MAC address, the same as our other access switch. So now that that's been accomplished, we should have the ability to get from the server to the client. Now, we didn't go through and actually do the ping. I didn't show you the ping that it was failing, but I promised that it was. There was one more thing that was actually happening here that was wrong. If we look at links 1 and 2, we want to take a look at the way that the access switch was configured for VLAN 20. So let's go ahead and look at that. If we do a show VLAN, we see we've got VLANs 1, 6, 10, 20, and 30. If we do a show VLAN 20, we can see that this is tagged on port 1. It's not tagged on port 2. That's what'll get you into trouble. You have 2 possible uplinks from that switch. If we're tagging on port 1, which if I just use a highlighter, that's going to bring all of our traffic in this direction. That's fine, assuming that everything is working, and that's my root bridge. If I'm not actually forwarding traffic over that link, if for some reason the root bridge changes from one point to another, why would that happen? Maybe you did a software upgrade on instance core A. Instance 1 moves over to core 2. Now we need to forward on this link. Spanning tree knows that we forward in that direction, but our tagging configuration doesn't match. The problem here is that we're not tagging on both possible uplinks. So what we'd want to do there is add it. If we go conf t VLAN 20, and we can just tell it tag, and then we tell them the port number. So in this case, tag 2. I know that's a little bit funny, especially if you're used to just having Cisco automatically tag everything in every direction. It's just the way that Procurve works. Each VLAN needs to be tagged on each uplink. You also use the term untagged, so instead of going around going switch port access VLAN 10, you can just say like VLAN 20 should be untagged on port 8. That would port 8 into that particular VLAN. Anything else to mention? Comware. Comware's a good one. With Comware, their trunk links are a little bit funny. A trunk link in Comware, let's just go through his configuration real quick. If we go down to interface 1 or 2, see here that it says port link type trunk. And then it says port trunk permit VLAN 1 and 10. The tricky thing with Comware is that it only supports VLAN 1 on a trunk link. So you set up a trunk link, it only supports .1Q of course. It'll go ahead and establish and it's up, but only VLAN 1 will move across the link. Why? Because that's all it allows by default. If it's a mixed environment, you've got Cisco gear, it's a little weird because Cisco allows all VLANs by default. So they've just kind of switched methods. I know a lot of customers that I work with will do specific whitelists on trunk links and say only these VLANs are allowed. So what you can do is actually, let's go over here and I'll show you real quick. We could say on that port, like conf t interface gig 1/0/1. I didn't need conf t because I'm in a Comware switch. And I'm already in system view, too much Cisco. And we just want to take this port trunk permit command, and we're going to say port trunk permit VLAN. And if you question mark, there's actually the all word. So this will behave kind of like the Cisco natural behavior where everything is allowed to go across the link. If you wanted to be more restrictive, then just using the default and doing specific VLANs that you want to allow would also work just fine. So 2 things to look at with your spanning tree configuration with HP. Let's just run through them real quick. We want to make sure that that our Mstp region configuration matches everywhere. A dead giveaway is if you've got a switch that's not one of your core switches. It's not some big beastly switch in the middle of your network. It's just some edge device, but it's telling you it's the root of spanning tree. If that's the case, it's probably a misconfiguration. So first thing, verify our region configuration. The second thing that we had to look at was what was going on with tagging. On HP ProCurve, we've got to tag each VLAN. And the third thing that we learned was with H3C, a trunk link only allows VLAN 1. So 3 things to watch for when troubleshooting layer 2 issues on HP switches.